let's say the difference between SN1 and SN2 reactions. So we are going to study about nucleophilic substitution reaction. As you can see, it can be of two types, SN1 and SN2 reactions. Okay, so what is the nucleophilic substitution reaction? When the nucleophiles substitute the leaving group and get attached to the alkyl carbon, this is our substrate and this is our the attacking nucleophile. Okay, if the rate of reaction depends on only the substrate molecule and not on nucleophile, it is SN1 because the power is 1 only. If the rate of reaction depends on both the substrate molecule and the leaving group, then we call it a SN2 reaction. Okay, let's quickly see more differences between them. Okay, so the first thing that you need to remember is SN1. The trick is you have to replace 1 with 2. Like SN1 happens in 2 steps. Okay, it requires 2-step. It's 2-step reaction. Okay, while this SN2 it requires only 1 step, single step reaction. I should write it with the red pen, single step reaction. Okay, and if I tell about SN1 reaction, it involves the formation of carbocation, do not involve the formation of carbocation, SN2. Third one, it requires only very weak nucleophile. Even weak nucleophile can attack this already formed stable carbocation, but we need a stronger nucleophile here. We need a stronger nucleophile here to undergo SN2 reaction. Why? Because there is no formation of carbocation, stable carbocation. We have to have a very good strong nucleophile which can attack on the substrate molecule and avoiding all the hindrance. Okay, since there is a formation of carbocation here, and you know carbocation is what? Planar. It's a planar molecule. So nucleophile can either attack from above or from below. There is a good possibility of both things. So we get a racemic mixture here. We get a racemic mixture over here. While here in SN2 reaction, since say for example I have a halogen attached to a carbon molecule and a nucleophile is attacking here, this nucleophile is going to attack from behind. Okay, to avoid the interaction with the lone pair of this halogen. Okay, that's why it attacks from the behind. So we get a inverted product. This nucleophile will be attached now here on the left hand side, not on the right hand side. Okay, just the example to show you. So you get a inverted product. You get a inversion product. Okay, it means what? SN2 is stereo specific. You get only inverted product. Okay, stereo specific, whether this is not. So this is our 5th point. Okay, if you want to see how this SN1 and SN2 happens, let me quickly show you. Like it involves 2 steps. For example, we have a tertiary carbocation and leaving group here. In the first step, this leaving group will leave, creating a drama. This is carbocation formation. Now this carbocation is obviously stable, so it will be attacked by the nucleophile. As I told you, this nucleophile will can attack from any side. Okay, this nucleophile is going to attack there, and we get both inversion product as well as retention product. Okay, but in the SN2 we get only inversion product. So that's all for SN1 and SN2. Thank you, and hit like button if you like the video and subscribe the video.